Hello. We are in Chapter 6, Section 6.2, the quadratic formula. In this video, we're gonna go over problem number 7, a real-life application, where we have an object that is thrown upward at a speed of 125 feet per second by a machine from a height of 5 feet off the ground. The height, which will be denoted by h of t as a function of time, of the object after t seconds, so that time will be measured in seconds, can be found using the provided equation. And we have 4 questions to answer. First one is, when will the height, that means h of t, be exactly 18 feet? So since h of t is supposed to be equal to 18 feet, we have to solve the equation 18 equals negative 16t squared plus 125t plus 5 for t. This is a quadratic equation. We usually like to keep the leading coefficient positive, so we're going to add 16t squared to both sides, subtract 125t from both sides, and then subtract 5 from both sides. So this is plus 18, and we're going to subtract 5 on the left as well. So that's going to lead us to 16t squared minus 125t plus 13 equals 0. And now it's the matter of solving this quadratic equation for t, obviously acknowledging that t should be positive because it's time in our real-life situation. Now we know that the fastest and best method for solving quadratic equations is factoring, but this one isn't actually factorable. Next one would be completing the square or using the quadratic formula. And I have to say that these coefficients are pretty big in here, and since we have no common factors on the left-hand side, we cannot divide anything out, so it might be best to use the quadratic formula with a of 16, b of negative 125, and c of 13. Just to remind you, the quadratic formula is, in this case t of course, equals minus b to start on top, which in this case is the opposite of negative 125, that means positive 125, plus or minus the square root of the b squared, negative 125 squared, minus 4 times a times c, so 4 times 16 times 13, all over 2a, 2 times 16. The number under the square root turns out to be 14,793. 2 times 16 is obviously 32. But that number doesn't have a nice square root. Moreover, it doesn't even have any perfect square factors. And therefore, we will have to just go with what it is. Once we plug it into a calculator, we get the 2t solutions for our quadratic equation in here to be approximately 7.71 and approximately 0.11. Now, both of those answers are positive, but it isn't really surprising. If that object is thrown upward by a machine from a height of 5 feet off the ground, then it's easy to imagine that very shortly after that, it will reach the height of 18 feet. But then it reaches its maximum height and starts falling back down, and on the way down before hitting the ground, it will pass through the height of 18 feet above the ground again. So those 2 times that are, to remind you, in seconds in our problem, definitely make sense that the object will be at the height of 18 feet at both of those times. I'll just add the unit in here, seconds, and as always, We can say or and in this case, because it's both of those times, approximately at least, at which that height is reached. The second question is, when will the object hit the ground? To hit the ground means to be right on the ground, so not at any height above the ground, but simply at the height of 0. So we have to solve the equation h of t equals 0. Very similar to the equation we had in part A, just this time instead of 18, we have 0 equals negative 16t squared plus 125t plus 5. And this time, instead of adding everything to both sides, let's simply divide both sides by -1 or multiply both sides by -1. And that will give us 0 equals 16t squared minus 125t minus 5. Again, we can try factoring, but it turns out that this trinomial is also not factorable. And again, as in part A, trying to complete the square might be very tedious and time-consuming, so let's just use the quadratic formula. So we're gonna have t equals, again on top, we start with minus b. In this case, it will be positive 125, since b itself is negative, plus or minus the square root of, now b squared is the negative 125 squared, minus 4 times a, so minus 4 times 16, and times c, negative 5. All over 2 times 16 as in part A. And also as in part A, that number under the square root isn't really nice, and we cannot simplify that radical. Therefore, we will just get the two approximated values. So we're going to have 125 plus or minus the square root of 15,945 over 32. And the two approximated solutions are 7.85 and negative 0.04. Now, still we're acknowledging that t is the time, so it cannot be negative. And it also makes sense because our object was thrown upward from a height of 5 feet off the ground, so not from the ground itself. And therefore, it will only hit the ground once on the way back, after about 7.85 seconds, which also makes sense because it's not much after 7.71 seconds when it was again at the height of 18 feet above the ground on the way down. Again, we dispose of this one. Next question is, when does it reach its maximum height? Whenever we have questions about a maximum, the largest, or anything like that, at least in this course, is when we are asking for the vertex of the parabola. We have already A, B, and C identified, so we can find the x-coordinate of the vertex, which we usually denote by h. This time I will just use capital case H for that purpose to distinguish it from lowercase h, which denotes the height of the object. But the formula will be the same. Minus b on top, so in our case, minus 125 divided by 2 times a, 2 times negative 16. So both top and bottom will be negative, resulting in a positive answer, and we get 125 divided by 32. Now, unfortunately, 125 and 32 have no common factors. 125 is 5 times 5 times 5, and 32 is 2 to the power of 5, so only multiples of 2. And therefore, this is our simplified form. Still, we are in a real-life situation where we need to give some approximated time, not a fraction. And 125 divided by 32 is approximately 3.91. Once again, the question is, when does the object reach its maximum height? And when is the question of time? Time is the input to our height function, not the output. And therefore, we will answer this using that first t, or time, coordinate of the vertex. So the object is reaching its maximum height after 3.91 seconds. Also, looking back at previous answers, it also makes sense. It was reaching the height of 18 feet at about 0.11 seconds, and then again after 7.71 seconds. So if we take the average of those two, which we expect to be when it reaches the maximum height, we will get exactly 3.91 approximated to 2 decimal places. The final question is, what is its maximum height, which is simply the matter of evaluating our height function at the x-coordinate of the vertex, in our case, t-coordinate of the vertex, 3.91, or really 125 over 32, and then simplifying that. So h of 125 over 32 will be equal to negative 16 times this fraction, 125 over 32 squared, plus 125 times that fraction, 125 over 32, plus 5. So that will result in negative 16 over 1 multiplied by 15,625 over 1,024, plus 15,625 over 32, and plus 5, which I will write as 5 over 1. Now, acknowledging that 1,024 is divisible by 16, resulting in 64, we get negative 1 in here, 64 in there. So it looks like we will be adding fractions whose least common denominator is 64. Therefore, I will multiply that second fraction by 2 on both top and bottom to obtain the denominator of 64, and the third one by 64 on top and bottom to obtain that denominator of 64 as well. So with the denominator of 64 on top, we are getting negative 15,625 plus twice 15,625. And if we have 2 times the same thing minus 1 times the same thing, we get 1 times the same thing. So it's going to be 15,625. And 64 times 5 is 320. So plus 320. And that results in 15,945 over 64. Mathematically, this will be the exact answer, but again, since we are in a real-life application, we need to give just an approximated answer using appropriate units. 15,945 divided by 64 is approximately 249.14. And we acknowledge that the height in here is measured in feet. So it will be about 249.14 feet for the maximum height of our object. And that will be it in this problem.